Hi everyone, today let's talk about chapter 11, Regression Analysis. So in this chapter, we only talk about one section, that is 11.1, the method of least square. Definition: given a random variable y, whose distribution depends on x, the relationship between x and the mean of y is called the regression curve of y on x. Today, we will look at the case when the regression curve is linear. That is, for any given x, the mean of the distribution of y is given by mu of x. We put mu of x here because we want to emphasize that this is a function of x, okay? But this guy is actually the mean of y. So you can think about this is the mean of y and of x. So it's linear, so it's alpha plus beta x. In general, y will differ from its mean. We denote the difference by epsilon, and we write y equals alpha plus beta x plus epsilon. So, as an example, okay, so this example, I put it on our course websites. This is the annual death rate from lung cancer. And here we have the percentage, and here we have the age group. So, the blue bar indicates the heavy smokers, 1 pack per day. And then the orange bars indicates the light smokers, less than 1 pack a day. And the green one is for non-smokers. So you can see the data sets follow like a linear relationship, right? So if how do we find the best fitting line? Well, if we have a set of data points, for example, this is the guy, right? We have a set of data points. How do we find the best fitting line? Well, we want to find the best fitting line such that the error, so here, these are the errors, such that the sum of the error square is the smallest. Okay? So, I will talk about that more. So this epsilon is the error and y is the actual value for y, and alpha plus beta x is the mean. Okay, alpha plus beta x is the mean, is the expected value of the y. Okay, let's look at example 1. By the way, so you can see right now, we have a set of data points. While in the previous chapters, we'll just talk about a set of numbers. So it's one-dimensional. So in this session, we're going to talk about two-dimensional. So we assume that the y depends on x. Okay? So example 1, a tensile ring is to be calibrated by measuring the deflection and various load. So x equals load force in thousands of pounds. Y is the deflection in thousands of an inch. So here you can see we have a table, x values and y values, they are points. So in Word, you can click Insert and then choose Charts and choose XY scatter. Then you can input the table and then draw a scatter plot. Okay, the scatter plot, you can choose the function to be linear or exponential or logarithmic or polynomial of any order. Okay, and so this is one example. After we plot the points, you can see it looks like linear, right? So we can choose linear, and then we can find the regression line. I know you have been noticing the COVID-19 is actually exponential growth. So for the COVID-19 number of infected people and the dates, you can choose the exponential regression curve. Then you can see it's actually quite fits the model of exponential function. So this is how you can find regression line from the Word. In your calculator, you can also find the regression line. So let me show you here. I use TI-30XS calculator. So you press data, and then you can see some columns. So in the first column, enter the x values. So we have 1. Oh. and 3, 5, 7, and 9. And then for the second column, enter the y values. So they are 16, 45, 86, 106, 134, 164. Okay. So the x I forgot to enter 11. So once you have two columns of x and y value, you press shift. So for my calculator, I press shift and then I do stat. And I click two variable stats. And then you can see x data is the column 1, y data is column 2, and then I calculate. Then my calculator will give me my n, which is 6. We have 6 data points. And the mean of x is 6. And the standard deviation for x is 3.741657. Okay, and remember the difference between S and sigma. S is this sample standard deviation. Well, when you compute the variance, you divide it by m-1. When you compute the delta, sigma is the population standard deviation. When you compute the population variance, you divide it by n instead of m-1. And we have the sample mean for the y values and the standard deviation for it. Okay, and this is sum of x, this is sum of x squared, this is sum of y, this is sum of y squared, this is sum of xy, and this is the regression line A and B. So those are the coefficients. But however, the coefficients in our calculator and the ones in our notes are flipped because I follow the notation in your textbook. So your textbook's A is actually the B in your calculator, and your textbook's B is actually the A in your calculator. So be careful with that. So please learn how to use your calculator at home. Okay? So yeah, a different calculator, you're gonna press different button. All right. All right. So how to find the best fitting line? Given n pair observations xi, yi, suppose the regression line is y hat equals a plus bx, where a and b are real numbers. Then the error. So let's draw the data set. So suppose our data set is like that. Okay, so this is x1, y1, and this regression line is the best fitting line. So you can see this height is actually y1 hat. Okay, this is y1 hat, and this is y1. So you can see the difference between them is the error E1. And then this is E2, this is E3, this is E4, and this is E5. So those are the error terms, okay? So error term is the difference between yi, the data point, minus the yi hat, okay? The corresponding points on the regression line. So we want to find a and b such that the sum of the error square is smallest. Well, when you compute the error, you want to compute the absolute value or like the square of it, so that all the errors are positive. You don't want to have like some error positive, some error negative cancel out. So, and also there are good reasons that we use square instead of square roots, because one of the reasons is we can differentiate square. So the procedure of finding the equation of the line which best fits a given set of pair data is called the method of least square. And A and B are the estimated values for alpha and beta. Okay, and here is the formula. How do we come up with this formula? First of all, let me define SXX. So let's define as xx to be sum of xi minus x bar square. So x bar is the sample mean for x. Okay, so what is this guy? Well, this is, we can expand it. So we have xi squared minus 2xi x hat plus x bar square. Okay, we can distribute the sum. So we have sum of xi squared minus, we can put the 2x bar outside of the sum, and we can put the x bar square outside of the sum, then we have the sum of 1. So sum of x, so that's why we get sum of xi squared minus, what is sum of xi? This is actually n times x bar, because x bar, the sample mean, is sum of the xi divided by n. So that's why here we have 2x bar and x bar plus x bar square, sum of 1, we have n copies of 1 adding together, that's n. So that's why you get sum of xi square minus 2n x bar square plus n x bar square. So we get minus n x bar square. So when we calculate, we use this formula. Okay, so this guy is definition, but when we calculate, we use this one to calculate. Similarly, when we solve for, when we define s, y, just replace x by y, and then it's the same thing, right? And this guy, when we define as x, y, is the sum of xi minus x bar times yi minus y bar. And what is that? I can show you here. So when we multiply it out, we get xi, yi minus x bar yi minus xi y bar plus x bar y bar. And then we have sum xi yi minus, so we distribute the sum. So we have sum of yi, we can move the yi in front of the sum, y bar in front of the sum of xi plus, this is x bar, y bar, distribute the sum, so we have sum of 1. Okay, so this is sum xi yi minus x bar, sum of yi is actually n times y bar. Sum of xi is x times x bar plus x bar y bar times n. Sum of 1, we have n copies of 1 adding together. So here we can cancel 1 copy. So that's why we have sum of xi yi minus n x bar y bar. Okay, so that is definition of sxx, syy, and sxy. Then the least square estimates. So the regression line is a plus bx. B is then equals sxy over sxx. And then A equals y bar minus b times x bar. How do we get this formula? Well, if you look at the last page of this notes, our goal is to have the sum of errors square smallest. So you can use some algebra to express the sum of the square in terms of this guy. Please look at this guy. You can see square is greater or equal to 0 here. So sorry. This guy square is greater or equal to 0. This guy square greater or equal to 0. So the only way make it smallest is when the square is 0. So that means we can solve for b. So set this guy equal to 0. We can solve for b. b is then sxy over sxx. And using this formula, we can solve for a. So a is y bar minus b x bar. So after we get all of these guys 0, then our sum of error square equals to this guy, syy minus sxy square over sxx. Okay, so this is the algebra. And let's go back to our formula. Okay. So the residue, which is the error term, that's EI. So residue sum of square, which is the error sum of square, we call it as SE. That is the sum of the EI square. Is then SYY minus SXY square over SXX. Okay. So this is the formula. It will be given in the final exam. So continue with example 1 and find the regression line. So I have shown you how to find the regression line from your Word and your calculator. So now let's do it by hand. So please listen carefully. So I'm gonna tell you what is the requirement? Okay, what's the requirement that you need to write? You need to show your work in the final exam. Okay, so from the example, so continue with our example 1. Do you remember when we input the data? We are able to find, x bar, y bar, sum of x squared, sum of y squared, sum of xy. So these numbers, you can get it from your calculator. Okay, so you can get this from your calculator. So because you know how to calculate, right? So x bar is you add all the xi's and divide it by n. So from the calculator we get this is 286, right? And y bar is the sample mean of the y values. We add all the y's and divide it by n. N is 6, so we get x bar is actually 6 and y bar is 91.83. The 3 is repeated. And then sum of xi square is all the xi's. Okay, we square it and add them all up. So you can get this from our calculator directly. We get 286. Sum of y squared is 65765. Sum of xy is 4333. So for these numbers, you can get it from your calculator. Next, what do we need to show in the exam? So here you're gonna show your work. So show your work in your homework or exam. Okay, so this is the work I require you to show. So once we know we get those values from the calculator, then we can use this formula. Okay, as xx is sum of xi squared minus n times x bar squared. Okay, so sum of xx is sum of x squared minus n is 6, x bar squared. Sum of x squared is 286, x bar is 6. Okay, so plug this in our calculator. Please do that. And I get 70. And then as xy is sum xy minus 6 x bar y bar. Sum of xy is 4333 minus 6, x bar is 6, y bar is 91.83. 3 repeated. Okay, it's good to keep the exact number from your calculator and put that number down here. Okay, then our answer can be more accurate. So SXY, that equals to 1027. Okay, then what is the B? Well, by our formula, B is SXY, so B is SXY over SXX. So SXY is 1027, SXX is 70. So plug this in our calculator. I got 14.67142857. Okay, that's my B. And how do we get the A? A is y hat minus b x hat. Y hat minus b x hat. Y hat is 91.83 with the 3 repeated. So it's good to put this exact number in your calculator. Your calculator has this number. And that minus B is 14.67142857. So it's good to keep that number, so the exact number from your calculator. X bar is 6. So plug this in your calculator and then you get 3.80476191. Finally, our regression line. Y hat is A plus BX. A is 3.80476. You can keep 5 decimal places. Okay, so keep 5 decimal places. And the B is 14.67143x. So let's check this answer with our Word document. Are they the same? Yes. So, and you can check this number with the one in your calculators, but your A-B values will flip. Okay, so then you will get the same answer. Alright. So in the exam, you can get this pink numbers from your calculator. You don't need to show your work for that. But for the blue part, you have to show all of this work in your exams. Otherwise, no credit. Okay? Let's continue. Example 2. The following are measurements of the air velocity and evaporation coefficients of the boiling fluid droplets in an impulse engine. Fit a straight line to this data. Estimate the evaporation coefficients of a droplet when the air velocity is 190 centimeters per second. Okay, so you can see here we have the X and Y data. I provide you the scatter plot of the words, but in the exam I won't provide that. So I provide here so you can check it with your answer. So how do we type this in our calculator? Example 2. Let's enter the X values. They are 20 and 100, 180, 260, 340. And then the Y values, we have 0.18, 0.35, 0.56, 1.18, 1.45. Okay, so and then I press shifts and stats, 2 variable stats, and calculate. So I get my N is 5, my sample mean is 180, my sample mean for Y is 0.744. Sum of X squared is 226,000. Sum of Y squared is 3.9634. Sum of XY is 939.2. So you're gonna need those numbers to calculate SXY and SXX. And then use the formula for regression line to find the B and A. You need to show all of your work in the exam, because here you see from the calculator you can get A and B directly. So you're gonna show all your work in the exam. Otherwise, no points. Okay? So at the end, but you can check your answer. You can that's why this is good to work on these problems. You always know whether you're doing right or wrong. You can check your answers to see whether it match with the numbers in your calculator. But keep in mind, the AB and the AB in our formula are flipped. Okay? Okay, let's put it down. So from the calculator, okay, we get X bar is 180, Y bar is 0.744, and here N is 5. We have 5 points. Sum of X squared is 226,000. Sum of Y squared is 3.9634. Sum of XY is 939.2. Okay, so, and then show our work in the exam. So with those values, how can we calculate? Well, as XX is sum X squared minus N is 5, X bar squared. Sum of X squared is 226,000, 5, X bar is 180 squared. So plug this in our calculator, and what do you get? 64,000. And SXY is sum of XY minus 5, X bar, Y bar, and sum of XY is 939.2, X bar 180, Y bar is 0.744. Okay, so plug this in our calculator, and I got 269.6. Okay, so my B is then SXY over SXX. So that equals 269.6 over 64000. So plug this in our calculator, and then what do you get? I get 0.00422125. Do you have the same answer? And then my A is Y bar minus BX bar. Y bar is 0.744. B is 0.00422125. And my X bar 180. So plug this in our calculators, and I get negative 0.01425. So far, so good. And so the regression line y hat is then a plus bx. A is negative 0.01425 plus bb is 0.00422125. X. And let's check our answer. Are they the same? Yes, they are the same, right? If you round up, you get 0.0143, and here you get 0.0042, right? So it's the same answer. But our problem is asking estimate the evaporation coefficient when the air velocity is 190. So we're gonna plug in y hat of 190. So that's negative 0.01425 plus 0.00422125. X is 190. So let's plug this in our calculator. Let's see what we get. Negative 0.01425 plus 0.00422125 times 190. I get 0.7 11.1a.mp4. Okay, so this is the estimate evaporation coefficient. Okay, so that is example 2. Do you realize in the process we didn't solve SYY? Why? Because in the process of finding the regression line, we don't need to solve SYY. But when you want to find out the sum of the error squared, you will need to calculate SYY. Okay? So we can calculate that in our next example. So let's continue with video part B.